think it's probably, would say our recommendation is that the state file should be broken down to something much smaller than the entire stack. So like each component
Yeah.
in the stack should have its own state file, like nothing much larger than that, just for safety
Yeah,
reasons.
I think I misinterpreted Pepe's question as thinking of state backend. But yeah, so every single component has its own state for every single environment or stage or whatever your internal terminology is for that. We use the word stage. So there's a state for EKS in prod. There's a state for EKS in staging. And going back to like this cold start problem we were talking about earlier is like when you optimize for day two operations, you actually end up with quite, at least in our experience, you end up with quite a lot of components. Now, if you want to optimize for day zero operations or like day one, like getting up and running fast, stick these in one component. Great. But now you have this massive state combined with everything. The blast radius is huge. Terraform figures out what needs to happen for you, but it's risky. So when you optimize for day two, you end up like, here you see we have ECR. We consider that its own component that we don't complicate with like an application.
There's something that I'd like to add to that. That we've been using that technique for a couple of years now. And just want to point out, any kind of splitting of state like that always has its pros and cons. It has a lot of nice advantages in that, as you say, you're breaking down the problem into smaller pieces. So for instance, we use it to split the management of cluster versus application deployments, right? So we have, say, one cluster can host multiple applications, maybe a test application or test version of the application, a staging and whatever, right? You get the idea. So the cluster itself is one Terraform state, and then each deployment of the app is another. That's nice. It works really well. The only thing you have to be aware of when you make that transition is that it becomes easier to break things between those different states, right? For instance, and maybe it's just the way we're doing it, but if you want to have multiple states like that, you'll end up using remote states in those applications, right? Because the test application deployment will need to know what VPC it's in and what's the cluster name and blah, 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 things like that. So it'll use remote state, the Terraform remote state of the base layer. Maybe that would be the top swim lane in your diagram earlier, right? If you make a change in that base layer, you don't know, you have to bear in mind that there's other states now that depend on that, right? If you change the output, you rename an output, you forget, that you've renamed it and that there was something using it. Now, next time you run the Terraform apply in your application, it's going to say, hey, that output doesn't exist anymore, and you've broken something. So it's just that I just wanted to point out that there's that little.
I love that you pointed that out. And that's a reality of doing this, and you decouple things, which introduces two problems. So one is you need a way to access remote state conveniently, and Terraform makes that relatively easy. You have the remote state data source, which we have abstracted away into this module called remote state, which fits into our opinionated way of dealing and organizing with things. So we have our Terraform YAML stack config. So this is how we handle now dealing with remote state very easily. We can just say, hey, give me the remote state of our EKS component for my current context. So we instantiate the state based on our current context and pass it here. I think this is slightly out of date, maybe. No, we don't use context because we want to specify which stack we want to get it relative to. Anyways, my point with this was leading up to the next thing is great. So remote state solves how we pass information, but it doesn't solve how we do the triggers. Like how do we automate when this thing updates, this other thing updates, especially in a decentralized team environment. And what we're talking about here conceptually is a policy. We want a policy that when our dependent modules change, we are updated. Because now suddenly there's things our Terraform module depends on which are not in Git. They're in some state somewhere. So this is where the tacos providers come in. Things like Terraform Cloud, Spacelift, N0 Scalar have ways of doing policies so that when your dependent things change, you can do it. And this is part of the crux of the problem when you're trying to do Terraform on roll your own, GitHub Actions, Jenkins, whatever. It's really hard to do and why I don't recommend it.
I want to add something, Eric. So
Yeah, go ahead, Mohan.
yeah, this is like a best practice. I tried. I was using remote state most of the time, and the point that Oliver said is so true. So my advice, guys, is that use data sources more than use remote state. With each Terraform AWS provider release, there is a new data source introduced. So let's say you want to have the RDS endpoint. Okay, you would use a remote state for your databases stack and get the RDS endpoint. But with the data source for RDS itself, you can call it from AWS itself. So you can query whatever on AWS with the data source. That will make it easier for you in case you update your RDS database. You don't need to worry about the output or remaining the output, because on all of these remote state, you need to manage your outputs. But if you
Yeah.
use the data source, you don't need to
That's
do
a good
that.
point.
So,
It
yeah.
is,
Good point.
although it definitely dovetails to needing a very sophisticated tagging system, especially in large environments, to make sure that you can do those queries and tie all those things together and identify using data source queries the things that you actually want to look for, which in and of itself can be almost as complex as managing the the remote state at some point. I've managed some very large environments previously that it was very difficult to use data sources, and that's why we ended up using remote state in a lot of places, because remote state was coming from a known path that we could just point to, versus like, how do we query for this, like
There's
in the whole universe.
there's a lot of other extraneous data you can put as well in the output of remote state, which might not be available if you're just using a straight up data source. So like discovering the VPC, yeah, that's a pretty good example. Just use a data source for that. But if you need some arbitrary account metadata that's available when you're provisioning the AWS accounts, but not available through tags or other things, you need to stick that somewhere, then that's a good place for it.
Like a database password would be a good example of that. Because once it's in RDS, you can't get it out. You can change it, but you can't get
I
it out.
think I think that's a really bad example of that.
That's a
Sorry.
touch. That is a bad example of when it's used. I mean, like the reality is that password is in the Terraform remote state, but shh, don't tell anybody.
Yeah. Or don't use that. Like change your root password immediately as soon as you provision an RDS cluster, and don't do it through Terraform.
Yeah.